In this video, we are going to explain why sine and cosine have particular values for special angles starting from 0, 30, 45, 60, and 90 degrees. To work out some of these values, we need to work in an equilateral triangle here, whose side is 1 and whose angles are all 60 degrees. And we will need to add the perpendicular height here. So for symmetry reason in the equilateral triangle, the intersection point here of the perpendicular height with the side is the midpoint. So we have here half on each side. And here it's bisecting the angle. So we have a 30 degrees angle here and obviously a right angle at the bottom right there. So let's now work in this right angle triangle here in blue. We know that the hypotenuse is 1, that this side is half. Let's use Pythagoras theorem to work out the length of the third side. So we can write that 1 squared, the hypotenuse, is equal to half squared, the side at the bottom, plus x squared, x being the missing side here, the perpendicular height in the triangle. If we solve this, we get that 1 is a quarter plus x squared, meaning that x squared has to be 3/4, and so x is the square root of 3 over 4, which is the square root of 3 over 2. Let's add this length on our diagram, so we have the square root of 3 over 2 here. And from this length, you'll see that we can find out quite a few values from the one that we're looking for. So let's consider first the sine of 30 degrees. I have a 30 degrees angle right here, sine being opposite divided by adjacent. It's half divided by 1, so I can write that sine 30 is half. Cosine 30 is going to be the adjacent side divided by the hypotenuse. So it's going to be the square root of 3 over 2 divided by 1. So I get the square root of 3 over 2. If we now consider the 60 degree angle, here is this angle right there. So the sine of 60 degrees is going to be the side opposite to this angle. So it's this one divided by the hypotenuse. It's right there. So I'm going to get the square root of 3 over 2. You can notice, by the way, that this ratio is exactly the same one as the one we've used for cosine 30. Yeah? So this shows that basically the cosine of an angle is equal to the side of 90 degrees minus this angle. But let's move on. Now, if we want to consider the cosine of 60 degrees being here again, we do adjacent divided by hypotenuse. So half divided by 1, I get 1/2. So we're done with the 30 and 60 degrees angle. Let's now deal with the 45 degrees angle. To do so, we are going to look at a triangle that is at the same time isosceles, with a side of length 1 here, and right angled. Because this triangle is right angled here, you know that the sum of these two angles here is going to be 90 degrees, because the three of them has to be 180. And because it's isosceles, the two angles also need to be equal. So they add up to 90 degrees and they're equal. This means that both of them must be 45 degrees. If we then use Pythagoras theorem to work out the length of the hypotenuse in here, we can write that x squared, the hypotenuse squared, is 1 squared plus 1 squared. So x squared is equal to 2. So x is equal to the square root of 2. Let's add this to our diagram right here. So let's now have a look at the sine of 45 degrees. 45 degrees angle is here. The sine is opposite divided by adjacent. So this sine is equal to 1 over the square root of 2. If we rationalize this, the denominator of this fraction by multiplying by square root of 2 here and there, then we get square root of 2 over 2. So this means that this sine here is square root of 2 over 2. You can notice that we get the exact same value for cosine 45 here. The cosine of this angle being adjacent divided by hypotenuse, it's 1 divided by square root of 2 again. So we find square root of 2 over 2 again. So we're almost done. We only need to find the value for sine and cosine at 0 and 90 degrees. And to do so, we will need to have a look at another type of triangles. To understand what's going on here, we need to look at a sequence of right-angle triangles for which one angle is getting smaller and smaller, until ultimately being completely flat. And we'll have a look at this angle here that's getting closer and closer to 0, the red angle. You see that another angle, the blue one here, will get closer and closer to 90 degrees as this right angle triangle gets flattened. So to understand what the sine of 0 degree could be, we have to look at the red angle here. We know that the sine is equal to the opposite side divided by the hypotenuse. Well, you see what's going on with this opposite side? It's getting smaller and smaller, and the hypotenuse has a given value. So if this actually gets really, really small, we see that when this angle becomes 0 here, the sine is going to be 0. For the cosine now, if you look at what's going on, cosine is going to be adjacent divided by hypotenuse, so adjacent divided by hypotenuse, adjacent divided by hypotenuse. You see that the two vertices here and there are going to collapse on one another. So these two line segments actually in the end are going to be equal. So dividing one by the other is going to give us the value of 1. Inversely, now, if we look at the sine and cosine of 90 degrees, so we are now looking at the blue angle right there, the sine is equal to the opposite divided by the adjacent. So we are going to end up dividing this side by this side, and as we explained earlier, the closer you get with this angle of 90 degrees, the closer these two lengths get together, and ultimately this ratio is going to be equal to 1. For the cosine of 90 degrees, we divide adjacent by hypotenuse, and you see that the hypotenuse has a given length, and that the adjacent side gets smaller and smaller to reach 0 ultimately, so this cosine is equal to 0. Et voila, we're done with explaining where these values are coming from. We are now going to record them in a table and explain a way to remember them a little bit more easily, because this is something that you need to know by heart for your exam. So here is our table with the values that we worked out before. You see these values, they look pretty random, so we need to find a way to remember them more easily. And here is this way. Actually, all of these values can be expressed as the square root of a number over 2. So let's see, what are these square roots? Well, 0 is obviously the square root of 0 divided by 2. 1 over 2 is the square root of 1, which is 1 divided by 2. Here we have naturally a 2 and a 3. And 1 can be expressed as the square root of 4, which is 2, divided by 2. So now you see we have a much more regular progression, starting from 0, 1, 2, 3, and 4. And so we have a more regular pattern that might be easier for you to remember. The nice thing is that cosine gets exactly the same value, but the other way around. Okay, so all you have to remember is that sine here has increasing values and cosine has decreasing values. The last tricky row can be completed using the fact that the tangent of an angle x is equal to the sine of this angle divided by the cosine of this angle. So to work out this value, for example, you need to divide this by that, or let's say this by that. So let's do it. 0 divided by 1 is going to be 0. Then half divided by the square root of 3 over 2 can be easily worked out. If you try and do this, you can remember that dividing by a fraction is multiplying by the reciprocal. These two 2's here are going to cancel out, and so we have 1 over square root of 3, which can be rationalized if we multiply by square root of 3, numerator and denominator, and so we get square root of 3 divided by 3. So that's our value here for the tangent. For the tangent of 45, we need to divide this number by this one. Well, these two things are equal. So if you divide one by the other, you get 1. For the tangent of 60 degrees now, we need to divide this number by that number. So we get the inverse division compared with what we had for 30 degrees. So this is the square root of 3 over 2, multiplying 2 over 1. Again, we cancel the 2's, and we end up with square root of 3 over 1, which is the square root of 3 here. And for the last one, we need to divide 1 by 0. Well, you know that you can't divide a number by 0 because the answer would be infinitely big or small, regarding the fact that it's positive or negative. But anyway, for us, it's not allowed, so tangent 90 degrees does not have a value. For later purpose, when we're going to have a look at the graph of tangent, you can keep in mind that it's actually an infinite value. So this is it. We've completed this table. We've explained where these values are coming from. Remember that these values have to be learned by heart because this is something you will use over and over again, and this is one of the requirements for your math exam.